This is the third page of Review Worksheet 8.1, 8.3. We're going to identify the X-Intercepts. That's where the numerator equals 0, and in this case it can never equal 0. So no X-intercepts. The vertical asymptote is where the denominator equals 0. And then that's what they're asking for, X-intercepts and vertical asymptotes. The X-intercepts are where the numerator equals 0. So you set your numerator equal to 0. This is a quadratic, so the way you solve for a quadratic is to factor. What two numbers multiply to be positive 12 and add to be negative 7? Zero product property. So x equals 3 and also x equals 4. Those are where the graph's going to cross the x-axis. And we have our vertical asymptote where the denominator equals 0. So it looks like we can fill them in here. We would have x equals 3 and x equals 4. And our vertical asymptote is also going to be x equals plus or minus 6. Here I could put them on their answers and create no X-intercepts and x equals plus or minus 2. Here we need to take this equation and identify which graph it is. We see here that it's going to have an X-intercept of 0 because that's where the numerator is. So this graph has x equals 0. This graph has x equals 0. This third one does not. So I can pretty much eliminate there. My vertical asymptote, x squared minus 4 equals 0. X squared equals 4. X has to be plus or minus 2. It looks here that this is x equals negative 2. This one looks like it's x equals 2. And in this case it might be x is 1 and negative 1. So again, that justifies why graph A matches our equation. Coming up for our graphing our rational equation, we're going to look for our vertical asymptote. Vertical asymptote is where the denominator equals 0. Have a horizontal asymptote. That's where you look at the leading coefficients, or that's where you look at the degree of the numerator compared to the degree of the denominator. If they were the same, we would look at the leading coefficients. In this case, the numerator is smaller. The degree is smaller than the denominator, which tells us that it's y equals 0. So if our vertical asymptote is 0, we put that in our box here. We're going to pick values, negative 1, negative 2, negative 3. When we plug in our points, when x equals negative 1, we would get 2 plus 3 over negative 1 cubed, which is going to be 5 over negative 1, which is negative 5. When x equals negative 2, we're going to get 4 plus 7 over negative 8, which gives us negative 11/8, which gives us 1 3/8, which is negative. When x equals negative 3, we get 21 over negative 27, which can reduce to negative 7/9. When we do the positive sides, we'll be squaring to get positive numbers. We'll be cubing and still get positive numbers. So our results will be the same, but they will be positive results compared to what we got on the left-hand side of the vertical asymptote. So to graph this, we're going to go to our vertical asymptote, which is x equals 0. Go to our horizontal asymptote, which is y equals 0. Plot our points. You can see that this first branch is going to approach the asymptotes nice and smoothly. And the second branch, write your equation. To fill in our chart here, the vertical asymptote was x equals 0. The horizontal asymptote was y equals 0. The domain is all real numbers except x equals 0. And the range are all the y values except the y equals 0, which is the x-axis. Last one, we're going to graph our equation. We're going to look at our vertical asymptote. We're going to take our x squared minus 1 and set it to 0. Take the square root. You get plus or minus 1. The horizontal asymptote, the degree of the top, which is 0, is smaller than the degree of the bottom, which is 2. So you know that it's y equals 0. We're going to plug our negative 1 and our positive 1 in for the vertical asymptotes. We'll start in the middle. A value that's in between 0 and 1 is a half. The next value to the right of that vertical asymptote would be 2, 3, and 4, negative a half, negative 2, negative 3, negative 4. When you start to do the calculations, when you plug in 0, we're going to get 0 minus 1. So 5 over a negative 1 is negative 5. When we plug in a half, we're going to get 5 over a half squared, so that's 1/4 minus 1, which gives us 5 1/4 minus 4/4, which is 5 over negative 3/4, multiply by the reciprocal, and we get negative 20/3, which is negative 6 2/3. Negative 6 2/3. When x is 2, we're going to get 5. Square the 2 to get 4 minus 1, so that's 5 over 3. 5 over 3 goes in 1 with 2/3 left over. When x is 3, we get 5 over 9 minus 1, 5 over 8. a little bit more than half. And when x equals 4, we get 5 over 15, which can be reduced to 1/3. When we plug in our negative numbers, we're going to get the same result for those. Negative half squared is just going to turn it to a positive number, positive 1/4. Do the rest of the math, and we're going to get 6 2/3, 1 2/3, 5/8, and 1/3. So when we come over to our graph, we're going to put in our vertical asymptote. It looks pretty close together, but it'll all fit. X equals -1, x equals 1. Be sure to label your graphs. We have a horizontal asymptote at 0, y equals 0. Plug in our points. At 0, we're down at -5. When you're at a half, you're at -6 2/3. When you're at 2, you're at 1 2/3, 5/8, 1/3. So this side is approaching the asymptote here. On the other side, at -1/2, we're going to be up at 6 2/3. So this is one of those funny graphs I've talked about. It is going to cross the x-axis. It's going to cross the horizontal asymptote. That's okay. You can't cross the horizontal asymptote at the extremes, which are the right and the left. -2, we're up at 1 2/3, then 5/8, then 1/3. We get y equals 5, x squared minus 1 is our graph. Our vertical asymptote is x equals plus or minus 1, so our domain is all real numbers except x equals plus or minus 1. The horizontal asymptote is y equals 0, so all of our y values, the range, can be all real numbers except that asymptote.